8 FANUC710 robots and an index table for a circular assembly line. On the screen, you can see the last demonstrations. 8 FANUC710 robots as a linear assembly line for the vehicle factory. Today, we'll lay these 8 robots around the index table as a circular assembly line. Before we start it, I have to say last evening around 10 o'clock, someone ring me and wake me up, but without speaking anything, and hand off the phone, and I continue to sleep. At 2 o'clock in the morning, I wake up and I found I get a MP4 video from the Department Naval Architecture and Marine Engineering of Chengkong University. The president of the union passed a video which we taking a sailing from Tainan to Kaohsiung. This video with a lovely song named Sailing, which the singer is Rod Stewart, a popular song. Quite nice music. I am sailing, I am sailing on again across the sea. I am sailing stormy waters to be near you, to be free. I listened to this song almost for whole days. Okay, let's go back to our topic today. First of all, we have to introduce what is index table. This picture I get from Taiwan Sun Li Fa, which is 6 stations Polish assembly line. In the middle, you can see a round table, which is named index table, controlled by I/O. As you input a I/O, then it will turn 60 degrees. Another input, it will turn another 60 degrees, and so on. This is index table. Today, I prepare a round table as well by SolidWorks. With radius 1.5 meters, and rounded by 6 FANUC710 robots. And I prepare a CSV table already. Let's see the demonstration. First of all, use new to clear the screen, and use scene input and the name of scene from the CMS GAC data file folder to adopt this one, 8 FANUC710 index table, and open this file. You can see 8 robots around an index table. The index table with the scar at station 1 at the x-axis at a 0 position, home position. After one operation with one I/O, the index table will turn 45 degrees with left hand rule, so the scar come to here. The gap will come to here, and the program will start it. 8 robots will work all together according to the teaching data. The first stations state the S file of index table. The index table is object 0. And the station 1 without any arrangement. That means it's just a state at the home positions of Cartesian coordinate system. While the station 2 is the first robot, is to control the first robot. First robot is this one. And station 3 is the second FANUC710 robots, and so on, until the last one, station 9, control the 8th robot. Totally is 8 robot, and with one index table. Totally is 9 stations. The maximum stations controlled by CMS CAPP, this program. Before we demonstrate the video operation of the script, we see the CSV file first. We go to the CMS GAC data to find the 8 FANUC710 index table. This one, 8 FANUC710 robots with index table, and open it. open this CSV file. This 2 means the first station ended at this line. In the first stations, only object 0 is Indextable.x. Attached to 0, translocate is 10. 10 means the 8 parameter thereafter is a state. The viewport, the first 3 is for the viewport's pivot points. That means where the camera located in 3-dimension coordinate. And the next 3 parameters, N1, N2, N3, is the view direction. Is the camera located at this position, and look the direction state at N1, N2, and N3. The first lobar ended at this 2, and the width at the foundation we shift to x 2.5 meters and rotating around z-axis 180 degrees. The rest 7 robots all the same like previous. Let's go back to CMS CAPP to see the program. As the file be adopted by scene input and the nav scene, then display on the screen like the show on the screen. And then the script the P2 test A is the script for the P2. P2 is the second station. That means for the first lobar, the first lobar started from the second stations. The P2 test A until P9 test A. The contents of the CC file all the same. Teach once, used for 8. But the name has to be specified. P2 is for station 2, P3 to control the station 3, etc. Until P9 test A.cc control the 9th station. That means to control the 8th lobar, this one. This A lobar's operations is all the same. While P1 test A.cc is the control CC file. As the input I1, input 1 be activated, then the value 0 becomes 1. Then P1 test A.cc be activated. The program will start it from late input 2, input 3 until input 9. The value 0 become 1. Then P2, the second station until the 9th station's robots operated according to the scripts stated in here. and waiting for several minutes, several seconds, and cease the input value to let 1 or become back to 0. And the program will finish soon. Before finished, the program finished, what next the system has to do? The system have to turn the table 45 degrees to prepare for next assembly. With an I/O, the object 0 of station 1 with the script K27 to let the table turn around the 0, positions according to the left hand rule 45 degrees. This gap will go to these positions, and the system will activate the input 1 to let the operation started from the beginning. But we turn the table 40 degrees before operation for the next assembly. The program let the system delay 2 seconds, and the program will start it assembly again. The system will run again and again. Let's see the P1 test A.cc, the program inside. While in teach more, at number 1 control station, we can load the CC file into the data field. We have seen the control file is P1 test A.cc. The program shown on the screen right now. K20 is open I/O. The I/O 9 in X position. That means the input I/O 9 from 0 be opened to 1. Someone argued to me, the input I/O cannot be opened by the software. If you don't like it to put on here, maybe you can write the script at the real. We always use input 24th FATEC PLC and the output for 16 ports. So 1, 2, 3, 4, 5, 6, 7, 8. One less. Still one less. So just put here. Don't worry. The software can manage to let you say open input 9. The input 9 will open, although the PLC light not on. But the computer input 9, the variable changed from 0 to 1, and the P9 test A.cc be activated. So open the 8th station, open 7th station, 6th station, 5th station, 4th station, 3 station until second station, 2 station. So P2 to P9 all be activated. 8 robots running according to these scripts. And the K22 is delayed 2 seconds. And the K21 is closed IO input 9. So as open the station 9 from 0 to 1, and this moment K21 9, the 1 will become 0 again, while the P9 tester A.cc is operating at that moment. And sys station 8, 7, 6, 5, 4, 3 until 2. Until 2, the first robot, the station 2, is closed, but the second robot, the station 2 robot, still running according to its tester 2 P2 tester 8.cc, still in operating. At last, the line 18 closed the first station. The control CC file be closed as well. And here delayed for 12 minutes, 12 seconds. This video has to be adjusted according to these 8 robots to see which one take longer, the longest for the operating. Last time we used 10 seconds. Right now we correct it to 12 seconds. It seems much better. You can see the robots stopped, and then the table running, turning 45 degrees. If you delay for 10 seconds, the robot stops. At that moment, the table turning to hurry to turn. So with 12 seconds is much better. And then most important, we introduce K27, the X file turning. We know, as the shown at the beginning of the speech, the index table is located at station 1, and the object 0, the index table's object number is 0. 27, the object position is in this position. So 0 means the index table. The 27 turn the table around the x-axis 0 degrees, around the y-axis 0 degree, but turning around the z-axis 45 degrees. At a power point x0, y0, turning around z coordinate, the z value don't care. So after K27 executed, you can see the table turning 45 degrees right hand rule. If you want the table turning counterclockwise, then here you have add a minus. That means minus 45 degrees turning around the Z axis. Then the table will turning counterclockwise 45 degrees. After located at the new positions, the system, the program here, wait for 2 seconds to let everything settle down. And most important, the last line, K20 is to open an I/O, and the input position 1 is station 1 be actuated from 0 to 1, and P1 test A.cc be actuated. Then the program will running, the 6 robots will operating, and the system running, and so on. Okay, let's run the script by PLC mode. As I press the button at here, the system will running and running for whole day, whole night, until stopped on purpose. Okay, let the program run, and we end the demonstration.